Okay, in this video we're going to look at Project 5A, which uses parallel arrays, and you'll need to have a copy of the PDF probably printed out. I'm going to try to keep it on the screen, but there's no guarantee I'm going to be able to do it. I'm not going to look at 5 because Project 5 is simply an expansion of in-class Lab 7. So it's pretty simple, and I don't think you need any help with that. If you do, then you probably need help with something else, like withdrawing from the course. But in any event, let's take a look at the specifications here together. It says using two parallel arrays, which you're familiar with because we talked about that in class. Create a decimal to Roman numeral converter program. So what this does is it takes a decimal number from the user and converts it to its Roman numeral counterpart. Now I've given you the algorithm here, so I'm going to kind of go over some of the, shall we say, the more problematic areas and leave the rest of it to your mind and intellect. Below is an algorithm that will convert any positive integer less than 10,000. All right, well, there's some limits on what they can give you here. The integer has to be less than 10,000. The reason for that is anything 10,000 or above can require overscores. We can't do overscores. And so in order to make this a simpler program, we're going to just, limit it, all right? And you'll be glad that I did. It says here less than 10,000. So 10,000 is out as well as 10,001 and so forth. And greater than 0. Okay, into its Roman numerical equivalent, and there's a chart here and gives you the Roman numeral, and then its number equivalent. The algorithm compares a series of values in the number being converted. Each item in the series represents a specific numeral letter or a pair of letters representing a subtraction. All right, there's a key in there, and I've given you the algorithm for all this, so you really don't have to worry too much about the math. The key numerals will be M is 1,000, CM's 900. So anyway, I mean it's right there, and it says to hold these values and link the integer to the numeral, we will use two parallel arrays. The base 10, that's our number system array, is called base 10, and there are 12 items in it. 1,900. Now that's 1,000 stored at 0 index, 900 stored at 1, and then the numerical equivalent, or the Roman numeral equivalent, is stored at the same indices all the way across. So that's how you initialize the arrays. Now I'm not going to go through all of that because it's a lot. All right, and you can do that. You already know how to initialize arrays. Just make sure that you start from the left and go to the right. So Step 1. Now you need to read this and understand it. You also have some input on the next input-output screens on the next page, but I'm going to help you with that. So get the user base 10 number, storing it in the variable location called number. So we're going to need a variable called number. Right? All right. Let's go over here, and we got num, and it's called number. Right, I'm going to initialize it to 0. Okay. All right, so that's that one. Now, obviously, this is a comment to you. That doesn't mean anything to the program. That just says, okay, you got to declare initialize your arrays. I'm not going to do that. All right. So it says here, if the user typed a -1, terminate the program, else go to the outermost loop. Well, there's an outermost loop here. All right. That tells you one thing right there. There's an outermost loop that does nothing but look at the number they give you to make sure they don't want to end the program. Actually, any negative number will end the program. So when we get into the data validation, you'll see how that works. Step 3, loop through each indices in the numerals array using a for loop. Well, that tells you there's a for loop inside of that outermost loop, right? And I've given you the limits here for, the loop control variable is called I. All right. We start at 0, we go to 12, and we increment by 1. Step 1. That's what I++ means. I get this every time. All right. Step number 4. While inside the for loop, if the number being converted is less than the test value, diminish or subtract the number value, and append the corresponding numeral or number pair to the Roman numeral output string. You can use a while loop. Now, you've got an outermost loop, then inside of that you got a for loop, and inside of that loop you have a while loop, and I've given you the code here for that. All right, and there it is, while number greater than or equal to base 10i, which happens to be the indices, the outermost loop of the for, which is the second loop. While that's true, number equals number minus base 10i, and then you're appending that numeral to your string output. So there is the parallelism right there. So let's take a look at that, and there's your parallelism right there. Okay, so you're setting up the number, and then you're outputting that same numeral from the parallel array at that same indices. Okay, and then step 5 says output the string output variable and display the conversion to get another number and convert and repeat step 2. All right, so as long as they want to keep going, we're going to keep going, and that's that outermost loop. All right, we're going to need another variable here to hold our output. Again, this is of type string, and we call it str output, and we set that equal to an empty string. All right, no big deal. We're going to need crlf again. That's of type string. It's a constant, and you know how to do that, hopefully. And I'm not going to worry too much about that one. All right. The next thing we need to do, according to this, to the specifications, is to get the user base 10 number, which we're going to be storing in the variable called number. So we're going to need a loop, a post-test loop. Now, I'm just going to do a while here, and I'm going to use a post-test. So we'll just do, let's see how I can write that. Do. It's actually a do loop when it's post-test. Whoops, excuse me. While, and sorry, I'm going to leave this blank and let you fill it in, but I'm going to put a comment over here. Okay, what are the constraints on the number? Well, it can't be a 0. If it's negative, we got to end the loop. All right. So there's a possibility here, right at this point, before we ever get into this thing, they want to exit and just stop the program and go to the bathroom, whatever. So if they give me a minus number here, we'll never go into that outermost loop, and it'll end. Okay. So any negative number will end the program. Now, another thing to remember is this particular do while, that's this while loop post test that you're doing here, you're going to have that inside the outermost loop as well. So this is a sort of like a priming read, you might say. Okay. So we're going to get the number from the user. That's all we're going to do. This is nothing more than a validation loop. You've done them before. If you need to go back and look at one of the other programs. The difference, this is a little bit different in that the number has to be 1 or 999 or 9,999, okay, because it has to be less than 10,000 and greater than 0. So it can't be 0. You can allow negative numbers, okay, they're valid, and any number between 1 and 999,000. Excuse me, 9,999. One less than 10,000. You got me. All right, so here our number has to be between 1 and 9,999, right? That's one option. The other is that, well, that's the valid option. It can also be any negative number. All right? Can't spell number today. Those are valid. Okay, I'm going to put valid in here so you'll know. Now, remember that in loops and validation loops, we're not looking for valid numbers. We're looking for invalid numbers. So you're going to have to figure out what the invalid range is and continue to loop as long as they give you an invalid number. What's the invalid numbers? 0 and 10,000 and above. Those are the invalid numbers. The valid numbers are 1 to 9,999 and any negative number. You got to figure that out. Post-test while loop. So you get the number, display the fact, and if you go back and look, let's go look at, see if they'll let me do this. Second page. It says, please enter a number for conversion, less than 10,000. Any negative number to quit, right? So I don't remember what I put in there. Probably nothing. I can't tell what I put in there. It doesn't look like my numbers are showing up here. But in any event, so you're going to have a do while loop. All right, that is your data validation loop. We haven't gotten to the steps yet. Okay, now I'm not putting all the things in here you're going to need, but I'm going to give, this is just for a hint, all right? Okay, at some point in here, after we do some different things, not very many, one or two little things, we're going to have our outermost loop. All right, it says, okay, if the user typed in a -1, terminate the program, else go into the outermost loop. So I'm going to have an outermost loop here. Now this is not a post-test, this is a pre-test, so I think we can use a while loop. While some condition is true, what is that condition? What is the valid number or acceptable number? It has to be greater than or equal to 1 or greater than 0, right? I'll give you that one. Number greater than 0. All right. If the number's not greater than 0, we terminate the program. So it never goes in here. If they give me a minus number, well, this would be false, wouldn't it? Okay? It wouldn't be greater than 0. It would be less than 0. So this would never enter, and you would exit the program. And down here, I think if you look at the code, it says, output. Thanks for using blah, blah, blah. I'll let you worry about that. And it ends. Either way, you get that error, you get that exit message. All right. So there's our outermost loop. And inside here, according to what I've given you, it says loop through each indices in the numerals array using a for loop. Right? Well, let's see. You hear me shuffling paper here. Shuffle, shuffle, shuffle. Okay. So we have to put in our for loop. This is the sort of the intermediary loop. I'm trying to decide what I'm going to show you and what I'm not, but I'm going right by the directions here, so you can always go back to them and scroll back up. It says my for loop has a counter of I set to 0. It loops as long as it's less than 13 or equal to 12, and we increment by 1. So the step is 1. That's the default step. 4. Counter or the loop control variable is going to be called I. You need to keep that in mind. It's not number. It's not anything else. I equals 0. I equals 0. I don't know why it's doing what it's doing. It thinks that's something other than what it is. Why is it doing that? Hang on just a minute. Now I just generated a help file that I don't need. Back up. So why is it doing what it's doing? See, look at that. Well, it's a lowercase I, and that's a 0, supposed to be. All right, then it's I. Watch it change. Boom. Less than 13. Okay. And then I equals I plus 1, or step 1. I'm just going to write step 1 because you're going to be using visual logic, so step 1. All right, and then I'm going to indicate the end of the loop just for pseudocode purposes with the next statement, next for. That means it continues. All right, so there is my second loop according to the directions, which I have given you on page 1. It gives you all this. It's nothing new. You don't have to think about this. You just need to be able to read. It says while in the for loop, so we're going to be inside the for loop. Otherwise, it wouldn't be talking about being inside the for loop. Excuse me. If the number being converted is less than a test value, diminish or subtract the number value and append the corresponding numeral in the parallel array or number pair to the Roman numeral output string. You can use a while loop as indicated below. So this is a pre-test while loop. And I've given that to you as well. It says here, while number is greater than or equal to base 10, right? That's your base 10 value that you're going to be doing the lookup in, I. Now, that time it didn't do that. So these are I's as well. Don't forget that. That's an I. That's a lowercase I. That's a lowercase I. Now, why I changed it to what looks like a lowercase L, I don't know. But just remember that that's a lowercase I, and that's a lowercase I. All right, and that's a lowercase I, and that looks okay. While that's true, okay, and I'm going to go down here and put my end loop right here, end loop. All right, just so you'll know where we are. And you really need to understand what's going on with this. This is a very seminal project. Don't skip it. If you skip it, you're going to regret it. Okay. And I've given you the code, so it shouldn't be a big deal here. Number equals number. You don't even have to understand really what's going on, just how to construct it. It would be nice if you did. Base 10I. Okay, that's the first. Now this is step 4. And then we append our numeral to our output string. Ampersand numeral I. There's your parallel array. Okay, see these are parallel right here. So you're subtracting that number from the actual number and outputting or sticking in your output string. All right. Okay, so we got that. Once we get out of the for loop, we output the number and some other stuff. And if you look at the output, you'll see it says Roman numeral equivalent. The original number is blah blah blah, and then the output string for the Roman numeral. Okay. So, and again, if you're not sure what the output looks like, scroll down and look at the output. Roman numeral equivalent of 75 is LXX7 XD, and I probably put a 75 in there, obviously. And now I put a 12 in there. So that's what it looks like. Roman numeral equivalent of the original number I typed in is colon space and then the output string, which holds the Roman numeral based on this. All right. So that's all we have to do. So I'm just going to put output, and I'll let you look at that. Output Roman numeral is equivalent numeral. I'm just going to put blah, blah, blah. I'll let you figure that out. It's right there. Okay, and you can handle the concatenation and all of that. So it looks like it's all on one line, so you don't have a CRLF in there. Okay. In fact, I don't see a CRLF anywhere, so you may not even need that CRLF now that I think about it. But it wouldn't hurt to put it in there in case you do. You can take it out if you don't need it. You may decide you need it. All right. Yeah, a couple other things go on here. Just housekeeping stuff, which you should be able to figure out when you start seeing your output not be correct. Well, after all, it is a project. You have to think some for yourselves. Okay, then we have to get the next number. Step 5 says output the string output variable, display the conversion, and get another number to convert and repeat step 2. Well, here's where we got our number at. It's the same code. So you can copy and paste that right there. Okay, get the number. Whoops, let me push this all back. I have to line all this up properly. There. Okay. So we get the number, and then we do one or two more little things. And if they give us a negative number here, this will be false, and out we go. If they don't give us a negative number here, if they give us a valid number between 1 and 9,999, we're going to do another set of numbers. It's very simple, all right? We're not going to accept a 0, so that's going to keep popping up. And if they give us anything between 1,999, then we're good, out we go. If they give us a negative number, we're good, and out we go. If they give us anything higher than 9,999 or 10,000 and above, we just keep looping until they give us the valid number. So this loops as long as they give us an invalid number. You got to remember that. It's backwards from what a lot of you have been doing. All right, let me zoom out just a bit so you can have a look at this in its entirety. And I actually don't see a need for this, so you might want to just delete that. Maybe I've overlooked it. I can't remember. Let me see if I can get this squeeze up a bit. I keep getting emails from my buddy, Mr. Cruisewells, my colleague. Let's see, a little bit more. All right. There it is, folks. There's not a whole lot to it. You got to remember, this is a validation loop. I've talked about that. You've got to understand what it is you're doing here. Make sure this works before you ever move into this, or you're going to be in a world of hurt, because you've got to use this again right in here. Remember, and let me go over this again, you're looping as long as the number is invalid. Once it becomes an acceptable number, that loop terminates. All right? So the valid number is between 1, 9,999, because we've got to limit it to below 10,000, or any negative number. We will accept any negative number because they can type in any negative number to quit. Those are the valid ranges. That's not what we're interested in as far as this loop goes. We want to continue to loop as long as they've given us an invalid number. An invalid range is a 0 or anything greater than or equal to 10,000. I've just given it to you right there. Here's our outermost while loop, which ends here. Here's our sort of nested secondary for loop, which ends here. And inside of the for loop, we have a while loop. This code I have given to you. All right, I even gave you that. Shouldn't be very difficult. Once you get this working, you'll have to put that inside your while loop. And there's your output, and some things go in here, and that's your final message. Okay? All I can say is get after it and good luck.